Good morning, dear students. Last class I have finished the different types of problems on strictly increasing functions and strictly decreasing functions. I have selected like all these problems from exercise 6.1, 6.2. Today also we are going to solving some different types of questions on strictly increasing and strictly decreasing functions. At the same time, after completion of one or two problems on strictly increasing and strictly decreasing, then I'll start that tangents and normals. In case of tangents and normals, how to find out the slope of tangent to the curve and how to find out the slope of normal to the curve. At the same time, how to find out equations of tangent and normals to the given curves. About all this today we will discuss. And firstly, we'll solve some questions on strictly increasing and strictly decreasing functions. Let us now we are going to solving those questions from exercise 6.2. The first question, find the intervals in which find the intervals in which find the intervals in which the function f is defined by the function f is defined by f of x is equal to x plus 1 whole cube into x minus 3 whole cube. This is x plus 1 whole cube into x minus 3 whole cube is strictly increasing and strictly decreasing. Here they gave one function f of x equal to x plus 1 whole cube into x minus 3 whole cube. For that now we are going to finding intervals. In those intervals, how we are going to taking the given function is strictly increasing or strictly decreasing. About this now we are going to finding here. Now let us we are going to giving solution for this question. Let the given function f of x is equal to x plus 1 whole cube into x minus 3 whole cube. F of x is equal to x plus 1 into x minus 3 whole cube as it is. And to this take a differentiation with respect to x. Then f dash of x is equal to, power is there. First we must and should take a differentiation with respect to power, that is 3 into x plus 1 into x minus 3 whole square into, and again take a differentiation to the base In case of base, there in product now we have to apply here product rule, that is x plus 1 into d by dx of x minus 3 becomes 1 plus v into x minus 3 into d by dx of x plus 1 is x, 1 is d by dx of x plus 1 is 1, it is the total. Next, f dash of x is equal to, draw a line here, separate this part. F dash of x is equal to 3 into x plus 1 into x minus 3 whole square into x plus 1 into x plus 1 plus x minus 3 is equal to f dash of x is equal to 3 into x plus 1 into x minus 3 whole square, x plus x 2x minus 3 plus 1 minus 2 here. Next one is f dash of x is equal to 3 into x plus 1 into x minus 3 whole square take 2 common here, then we'll take x minus 1, because there in product now we can take this f dash of x equal to 3 into 2 6 into x plus 1 into x minus 3 whole square into x minus 1 here. Separate this is. Square is there for these two only, x plus 1 into x minus 3 only. But remaining part is x minus 1 now. Now from this step we are going to finding intervals. In those intervals we are going to finding which is strictly increasing and strictly decreasing. About those we are going to finding here. At the same time, you represent this equation number 1, because the given function is x plus 1 and x minus 3 whole cube. Now I have taken to this differentiation with respect to x. That's what I have taken differentiation to the power first, 3 into x plus 1 into x minus 3 whole square into remaining part is x plus 1 of 1 plus x minus 3 of 1 here. Then f dash of x equal to 6 of 3 into 2, 6 of x plus 1 into x minus 3, and remaining base is the product rule. It is there in product now. For that I have applied product rule of differentiation here. U into dv by dx plus v into du by dx. On taking differentiation to that part, we got 2x minus 2. Have taken 2 common here, 2 3 is 6. Next step is for increasing or decreasing. For increasing or decreasing. For increasing or decreasing. For increasing or decreasing, we are going to equating 0. F dash of x equal to 0 here. That is 6 of x plus 1 into x minus 3 whole squared into x minus 1 is equal to 0. That is all are equal to 0 means here x plus 1 is equal to 0 and x equal to minus 1 here. At the same time, x minus 3 is equal to 0, we got here x is equal to 3. Next last product is x minus 1 is equal to 0 and we got x is equal to 1. Like that here we got the 3 numbers. They are minus 1, 3, 1 here. Then afterwards we are going to plotting all these three numbers on a real number line. We got three numbers minus 1 comma 1 comma 3. Then we are going to plotting, that is allotting those on real number line. By taking allotting on real number line, we are going to getting intervals. In those intervals, then we are going to checking whether differentiable function is less than 0 or greater than 0. About that now we will discuss. Next part is we are going to allotting on real number line. Minus 1, here one side is this side is minus infinity, this side is plus infinity, here minus 1, here plus 1, here plus 3. Totally we have three intervals 1, 2, 3, 4 here. Three intervals we have here. Now we are going to take in the table here first. Intervals first one is sin of f dash of x. First one is intervals. Intervals. Next one is sin of f dash of x. Nature of f of x. First one is minus infinity comma minus 1. Totally we have four intervals. Second one is minus 1 comma 1 here. Third one is 1 comma 3 here. Fourth one is 3 comma infinity. Like that we have four intervals. Minus infinity comma minus 1 is there. Before minus 1 generally numbers minus 2, minus 3, minus 4, minus 5 like those numbers will come. Just if you can substitute minus 2 here. Already for these two square is there. That's why square is there means it is always positive. That's what that part becomes plus. And that part also totally that part becomes plus only. This part becomes always plus. The bracket part becomes always plus because square is there to this bracket part. That's why instead of this part, if we can write or we are going to writing positive only. Minus 2 is there. Minus 2 minus 1. Minus 2 minus 1. Minus 3. Minus 3 means negative. Plus into minus. Minus. Minus means it is the negative. Negative means here f dash of x is less than 0. Less than 0 means what we are calling this? Strictly decreasing function. strictly decreasing function. Plus next, minus 1 to 1. Generally, minus 1 to 1, before 1, generally 0 will come here. 0, minus 1, 0, 1 like that. Just substitute 0 here. 0 minus 1, we have to check about this only, because always it is compulsory we are getting positive in the bracket place. That's why just we have to checking for the second bracket only, enough here. 0 minus 1, 0 minus 1 becomes minus 1, minus means minus, it is plus into minus, minus, minus means it is also negative here. Negative, negative means f dash of x is less than 0. Less than 0 means what we can write? Strictly decreasing function. Strictly decreasing function. Strictly decreasing, enough, no problem. Next, 1 to 3. Before 3 generally 2, 2.1, 2.2, 2, 1.5, like those numbers will come. Better to select 2 enough. 2 minus 1, 2 minus 1 means plus 1, plus 1 means plus. Let it is plus into plus is equal to positive here. Positive means we can write here, it is the positive here. Positive means f dash of x greater than 0. Greater than 0 means we are calling this strictly increasing function. Strictly increasing function. Strictly increasing function. Next one is 3 to 4. After 3 generally which numbers will come? 4, 5 something will come here. 4 minus 1, if we can select 4 minus 1 plus, it is a plus into plus means plus, plus means it is the positive. Positive. Positive means here f dash of x greater than 0. Greater than 0 means what we can tell this is strictly increasing function. Strictly increasing function. Like that we are taking intervals for this. In first interval strictly decreasing, even second interval also strictly decreasing, third interval strictly increasing, and fourth interval strictly increasing function based on the differentiable function less than 0 and greater than 0. Like that we are going to finding the strictly increasing functions and strictly decreasing functions. But how to write strictly increasing or strictly decreasing, about that I will tell you now. Say yeah. Therefore, f of x is strictly increasing function. Strictly increasing function. Increasing function in the intervals. In the intervals minus infinity comma strictly increasing function. Here say this 1 comma 3 open interval 1 comma 3 union open interval 3 comma infinity, like that. And in each interval strictly decreasing, about that also we should write here. f of x is strictly decreasing function. F of x is a strictly decreasing function in the intervals, in the intervals, minus infinity comma minus 1 union minus 1 comma 1, like minus 1 comma 1, like that. We are going to representing the intervals like this: minus infinity comma minus 1 union minus 1 comma 1. In this case strictly decreasing, and in that case strictly increasing. Like that we give solution for in case of strictly increasing functions and strictly decreasing functions. Let us now we are going to solving another problem. Find the intervals in which find the intervals find the intervals in which the function f is defined by the function f is defined by f of x is equal to 10 minus 6x minus 2x square 2x square. This 10 minus 6x minus 2x square is strictly increasing and strictly decreasing. Strictly increasing and strictly decreasing functions. They are asking about this. Same for this also, you must take a differentiation with respect to x, and afterwards you are going to finding intervals. About all this now we will discuss. Let us now we are going to giving solution for this question. Solution: let the given function f of x is equal to 10 minus 6x minus 2x square. Differentiation with respect to x. f dash of x is equal to derivative of independent constant is 0, and it is 0 minus 6 d by dx of x is 1 minus x square difference is 2x, already 2 is there, 2 into 2 4x. F dash of x is equal to minus 6 minus 4x we got here. At the same time you represent that's equation number 1 here, and afterwards for increasing or decreasing we are going to equating that differentiable function is equal to 0 here. For increasing or decreasing, for increasing or decreasing, functions, For increasing or decreasing functions, f dash of x is equal to 0. F dash of x is equal to 0 here. That is minus 6 minus 4x is equal to 0. This implies minus 4x is equal to plus 6. X is equal to 6 by minus 4. On gets the cancellations, we'll get minus 3 by 2 here. 2 3 is 2 2 is plus by minus minus 3 by 2. X equal to minus 3 by 2 we got here. That implies we can write here x equal to minus 3 by 2. At the same time, we are plotting this real number on real number line. After plotting that on real number line, we will get some intervals. In those intervals, now we are going to checking the differentiable function f dash of x, where it is a positive or negative. About that now we will discuss. Say here, take one real number line. Take one real number line here. One side is a plus infinity, another side is a minus infinity, and middle stage it will come here minus 3 by 2 here. Same time should write here intervals. Intervals, first write intervals here. Next afterwards sine of f dash of x, and last one is nature of the function. Nature means we are going to have to decide that the given function whether it is strictly increasing or strictly decreasing. Now first we should write intervals here. Intervals. Next one is sine of f dash of x. Sine of f dash of x. Next one is nature of the function. Nature of the function here. First interval is minus infinity comma minus 3 by 2 here. Next one is minus 3 by 2 comma infinity, like that. Minus infinity comma minus 3 by 2 here. This is minus 1.5, it's nothing but this minus 3 by 2 means before minus 1.5 becomes minus 2, minus 3, minus 4, minus 1.5 here. Minus 1.5 means minus 2, minus 3, minus 4, minus 5, like those numbers will come in that interval. Just select minus 2 here. Bring substitute minus 2. Minus 4 into minus 2 plus 8. 8 minus 6 plus 2. Plus 2 means greater than 0. That is plus symbol will come here. It is a positive here. Positive means we can write, this is f dash of x is greater than 0. Greater than 0 means what we can write for this? Strictly increasing function. Strictly increasing function. Strictly increasing function. That's it. Next one is minus 3 by 2 comma infinity. Minus 3 by 2 comma infinity means after minus 3 by 2, after minus 1.5 becomes, after minus 1.5, minus 1, 0, 1, 2, 3, 4, up to and so on like that. Yeah, as you wish, you can select any one number in that interval. Minus 1, 0, 1 like that. My wish I am going to selecting 0. If you can substitute here, minus 6 minus 4 into 0, 0 minus 6 minus 0 minus 6 minus 6 means it is the negative symbol will come here, negative it is, negative. Negative means we can write this is the f dash of x is less than 0. Less than 0 means what we can write? Strictly decreasing function. Strictly decreasing function. Like that we are giving a answer for this. Strictly decreasing and strictly increasing. Strictly increasing in the interval minus infinity comma minus 3 by 2. Strictly decreasing in the interval minus 3 comma in minus 3 by 2 comma infinity. Like that we are giving solution for this question. Let us now we are going to solving another questions. Next one is prove that the logarithmic function prove that the logarithmic function prove that the logarithmic prove that the logarithmic function is strictly increasing is strictly increasing a strictly increasing function on the interval open interval 0 comma infinity, interval 0 comma infinity here. Say here, prove that the logarithmic function is strictly increasing function on the interval 0 comma infinity here. In the interval 0 comma infinity means exclude that last endpoint 0 and infinity. Just we must include only middle stage numbers here. Logarithmic function means here we must take a logarithmic function with respect to base e. See here. Now let us we are going to giving solution for this question. Solution is let the given function let the given function f of x equal to log x, f of x equal to log x to the base log x, or we can write like this also, log x to the base e. The base e you may write or you may not write as you wish. If there is no base to the logarithmic terms means just we must and should consider the base to the log is e here. That's what I have written in two terms, log x or log x to the base e. Now we take a differentiation with respect to x. That is f dash of x is equal to d by dx of log x to the base c is the 1 by x. It is equation number 1. We are not getting any numbers for this values for x because 1 by x need not be equal to 0. 1 by x, if we can 1 by x is equal to 0, then taking cross multiplication 1 is equal to 0, that's why it is not applicable here. See here, if we can take f dash of x is equal to 0, then 1 by x is equal to 0, then 1 0, but they are not equal. That's why we should not equate to f dash of x is equal to 0 here in the case of logarithmic functions. That's why 1 by x need not be equal to 0. Already they gave interval also. In this interval, other than 0 and other than infinity, you can take any number, it is always positive. See here, 1 by 1, 1, 1 by 2, some 0.5, 1 by 3, some 0 point something, 1 by 4, 1 by 5, 1 by 10. You can take other than 0 means you can take any non-zero real number in place of x. You are always getting those numbers are only positive. They are always greater than 0. That's what it is always positive. It is always positive for all x belongs to open interval 0 comma infinity. Therefore, we can write f dash of x is greater than 0. If f dash of x greater than 0, easily we can tell f of x is always a strictly increasing function. How means I will show you how to write in the words here. That is 1 by x is always greater than 0 for all x belongs to open interval 0 comma infinity. That is f dash of x is always greater than 0 for all x belongs to open interval 0 comma infinity. Therefore f of x is always strictly increasing function. Strictly increasing function on the interval 0 comma infinity open interval. Like that we are giving solution for this question. So always see, if we can observe logarithmic function, it is always the value of logarithmic function is always positive only. That's what I have taken f of x equal to log x to the base e. To that I have taken differentiation with respect to x. When if we can take a differentiation with respect to x, we got d by dx of log x to the base e is the 1 by x. 1 by x means we can't equate to 0. If we can equate to 0, we are not getting the values for x. We are not getting the values for x means we should not equate to 1 dash of x equal to 0. Because no need of equate to 0 also, because they mentioned the interval also in the question. They gave interval also here. See, they defined that logarithmic function in the interval 0 comma infinity only. Because that only we should not them equate to 0 here. Then f dash of x equal to 1 by x means in place of x other than 0, other than infinity. That means if we can take any non-zero real number, you are getting one positive real number. You can take any non-zero real number in place of x, you are getting only one positive real number. That is positive real number means we can write it is always greater than 0 for all x belongs to 0 comma infinity. Therefore f dash of x greater than 0 for all x belongs to 0 comma infinity. When it is greater than 0 means it is a positive. Therefore finally, I have written here f of x is always a strictly increasing function on the interval 0 comma infinity. Like that, I have finished some different types of problems on strictly increasing functions and strictly decreasing functions. Just you solve some extra problems also at your home. Just see the procedure, what I told, the procedure for strictly increasing function, strictly decreasing function. Just you have to apply that procedure to extra questions, just to solve them at your home also. Because I am going to start a new lesson next class. What I already I told also, I have told also that's name of the lesson is tangents and normals. About that I'll start on the next class. In that tangent normals, how to find the slope of tangent, how to find out the slope of normal. At the same time, how to find out equations of tangent normals. About all this we'll discuss on the next class. After this, I'm going to stopping that uh, all the types of problems on strictly increasing function and strictly decreasing function. If you want some extra questions, means just to solve them at your home, just to apply what I told the procedure for the strictly increasing functions and strictly decreasing functions. Next class onwards, I will start new lesson. That's the name of the lesson is tangents and normals. Thank you very much.